This is Algebra 2, Section 2.2, Revisiting Slope. The first thing we have is a definition for slope. Slope is basically a rate of change. It measures how much something increases over a constant measure of, usually it's time, but even if we have undefined variables. We have a usual formula for slope, and that is y2 minus y1 over x2 minus, come on, there we go. And that's a fraction. We like to use the variable m to represent slope. I should just do this. M equals y2 minus y1 over x2 minus x1. And if you kind of think about it, rise over run is the phrase that you probably hear a lot. Rise over run. Think about when you rise, that's going up and down, and y is the vertical or up and down variable. Run is the horizontal or side to side variable. So when you run, you're going across. So you do the rise divided by the run, and that's your slope. These x1, x2, y1, y2 variables come from when you have a pair of ordered points. Y. So that's supposed to say x1, comma y1, x2, comma y2. When you're given points, like we'll do an example down here where we have these points, you would substitute those values into this formula and it gives you your slope. This slope-intercept form is the same as the linear equation form from yesterday, y equals mx plus b, and again we call m the slope. Oh, it's so hard to write with this. And we call b the y-intercept. And we can flip those again. The y-intercept can first, or the slope can come first, but the slope is always with the x. So this first example says identify the slope and the y-intercept of each equation. Looking at this equation, it's that flipped version where my constant value, my x-less value, is the y-intercept. So I'll put a b there because that's the y-intercept. And my coefficient on my x is 3, so that's my slope. I'll put an m there because that's my slope. Same thing over here. My slope is 4. That's the number on the x. My intercept is 7. That's the constant by itself. Last one, my number by itself is 8, so that's the intercept. Now there's no technical number in front of the x, but what hopefully you recognize is when you have no number, no coefficient, it is what I call the invisible 1. So the slope in this case is actually -1 because of the minus and the invisible 1. Scrolling down, letter B says a line has points 3, 8, and 7, 16 and a y-intercept of 5. Find the slope of the line. Okay, so I'm going to label these points x1 and y1, x2 and y2, and I know that this is my intercept, so I'll put a b there. This isn't something that you have to do, but I would recommend, until you get your slope formula down, that you always label your points every single time. Now the slope formula that I wrote at the top left of the page is what we're going to do. That was y2 minus y1 over x2 minus x1. So I'm going to plug these values in. 16 minus 8 over 7 minus 3. That's 8 on the numerator, 4 on the denominator. 8 divided by 4 is 2, so my slope is 2. Now my equation in mx plus b form would be 2x plus 5. And we finish with everyone's favorite, the word problem. It says Darren's car gets 20 miles per gallon of gas, which means he uses 0.05 gallons for each mile he drives. He starts off with a full tank, 16.4 gallons. As Darren drives, he watches the gas gauge to see how much gas he has left. Write a linear equation in slope-intercept form to model this situation. So we're not going to use this number. What we're going to use is this one. So he uses 0.05 gallons for each mile, which kind of means that our slope is going to be negative, 0.05. Hope you can still see that. Negative 0.05. And since his starting value is 16.4, that's going to be our intercept. So negative 0.05 x plus 16.4. How much gas will he have left after driving 175 miles? So it's important to identify your variables. X is our representation for miles, and Y is our representation for gallons. So if I want to know how many gallons does he have, it means I'm trying to find Y, and he's driven 175 miles, means I know what X is. So I'm going to take my 175 and plug it in for X. So if I go negative 0.05, 175, plus 16.4, I get 7.65. So after driving 175 miles, there are still 7.65 gallons left in the tank. How far can he travel before he has less than 2 gallons remaining? So gallons is a Y. I'll put 2 in for Y. And then we have to solve the equation. We will start by subtracting 16.4 on both sides. The negative 0.05x remains the same. 2 minus 16.4 is negative 14.4. And then we're going to divide both sides by the slope. And we get x is 288. Which means he drove 288 miles to have less than 2 gallons left in the tank. Okay, that finishes the notes. Good luck with the exercises, and let me know if you have any questions.